Hey, what's up YouTube? A while back I started a series on creating realistic grass in Unreal Engine. In part 1, I explained how I created an efficient wind system using Niagara with controllable strength, direction, turbulence, and gusts. It's quite a solid system, and to this day I'm still very happy with it. In part 2, I did my best to explain how I built a very complex grass shader with features like an uncommon billboard technique to maximize pixel coverage, programmable bend, scale, clump, wind animation, and accurate normals. The vertex shader is thus a bit expensive, but this technique is definitely shippable if you know what you're doing and if you're quite aggressive with vertex count and LODs. My goal at the time was not to build a realistic grass shader that could run on mobile anyway. Quite the contrary actually. I was trying to see how far I could push this shader without worrying too much about performance for once. Now, as promised, here's part 3, where I'll discuss my workflow for creating foliage assets using Blender. I already did a video on creating stylized trees using Blender, so make sure to check it out. Now, today's video was severely delayed because creating foliage for real-time applications in Blender isn't a streamlined process. It's not overly complex, but the task is so specific that, well, Blender is not tailored for that precise use case, right? Thus, there are quite a few buttons to press to get there, let's put it that way. And at one point, I thought it'd be a good idea to create an add-on that would make my life much easier. But then things got a bit more complicated than anticipated, and I had other projects to finish as well, hence the delay. Anyway, now that I'm almost done with it, time to finally speak about creating foliage assets in Blender. So in this video, I'll show my step-by-step process to create this grass asset without using any add-on. And in a fourth and final part, I'll show what my Blender add-on aims to provide, how to use it, and so on. I'm quite happy with it, so stay tuned for that upcoming video. Anyway, enough rambling, let's jump right into it. First off, I'm going to delete everything. Then I'm going to create a camera. Shift-A, camera. Press Alt-R to reset its rotation. And let's offset it in Z. Cool. Now, let's check what the camera sees. Okay, so next I'm going to set this camera's type to orthographic. I may also change the width, whatever, not important. What's important, however, is the render resolution. So let's use 1024 and 512. Next, let's change the scene color management, very important. The view transform needs to be set to raw. And in film, I'm going to enable transparent. You may also reduce the filter size to sharpen your renders a little bit at the cost of some aliasing, up to you. 1.5 is fine. Next, I'm going to set the background color to pure black. Quite important to get rid of any ambient lighting. And that should be it for the setup. So that's the canvas I'm going to work with, okay? The ratio is driven by the render resolution, and the overall size by the camera's orthographic width. To better visualize this, I'm going to create a plane and scale it to match the orthographic width and render aspect ratio. Display it as wireframe. F2 to rename it to, say, canvas. And then prevent the object from being selected and rendered. I'm also going to turn off the grid and axis in the viewport. Personal preferences. Next I'm going to rename this collection to, say, scene. And create a new one named, say, high poly. So my goal at that point is to model the high poly foliage assets and lay them flat on that canvas. For the sake of this video, I'll stick to simple things. I'm going to create a plane, press Tab to enter edit mode, and press S and X to scale it along the X-axis. Then Ctrl R to add a vertical edge loop here. and I'm right away going to set its bevel weight to 1.0. Then Ctrl R again to add multiple horizontal edge loops using the scroll wheel. Next, I'm going to enable proportional editing and change the fall-off. Selecting the top vertices and using the scroll wheel to change the proportional editing radius, I'm going to press S and X again to create some kind of pointy end. This is a bit dull, so feel free to be a little bit more creative than this. Then I'm going to scale these edges along the X-axis as well. And then why not pull these two vertices upward a little bit by double tapping the G key and moving the mouse upward. Same with these, downward this time. Next, back into object mode using the tab key, I'm going to add a bevel modifier and set its limit method to weight. Reduce the amount and add one more segment. Then I'm going to add a subdivision modifier. Let's use 2 subdivisions in the viewport and 3 in the render. Okay, that bevel modifier doesn't serve much purpose though, yet. So using tab to enter edit mode again, I'm going to select this edge loop by holding Alt, Shift and left clicking on that edge. Press Ctrl I to invert the selection and H to hide vertices. Next, using proportional editing again, I'm going to select and pull that vertex up by pressing G and then Z. Alt-H to unhide vertices. Alright. This end here is a bit too sharp to me, so I'm going to select these 2 vertices, press Shift-S and select Cursor to Selected. Then I may use the cursor as a pivot point, so that I may reduce the thickness a bit around that area, still using the proportional editing and tapping S followed by Z. Let's change the fall-off to something pointy though. Yep, like so. It's still a little bit too sharp overall, so I may scale the object along the Z-axis, still using the cursor as a pivot point. Okay, apply the scale using Ctrl A, reset the pivot mode, and then I'm going to tweak the object's pivot point, like so. Finally, right-click, Shade Smooth. Oh, I might actually add a little bit of thickness using a Solidify modifier. Drag it above the subsurface modifier, tweak the thickness setting, and voila, that's my grass blade base model. First, I'm going to assign a new material to that object. Now, because the plane I originally started with is by default unwrapped like so, the grass blade model I ended up with should have a similar UV map, just with a few more edge loops. Using the slide operator to move the top and bottom vertices on the mesh should also have modified their position on the UV map, but no biggie. So to texture this grass blade and create the PBR passes, well, I could paint some grass blade texture using this UV map, say an Albedo texture, Roughness texture and so on. I'm however going to stick with a much simpler method and use gradients to create and output the PBR passes. And I'm going to use this UV map for that purpose. But first, I'm going to create a couple of shader AOVs. Albedo, Roughness, Specular, Opacity, that one can be of type value, Normal, Random, Height, and Transmission, why not? Next, in the Compositing workspace, I'm going to enable Use Nodes, and I get to see the shader AOVs I created listed in the Render Layers node. I'm going to create a File Output node and add and rename inputs to match these passes. Next, I'm going to specify the desired output path. PNG is fine, RGBA, 8 bits, and disable compression entirely for faster save time. Voila, at this point, if I do a render, I should see in the specified folder one PNG file for each pass. Unfortunately, as far as I know, the way they are named is kinda hard-coded. There's no way to get rid of that frame count in the name, for instance, so that's really annoying. A quirk in the workflow that my upcoming add-on aims to solve, amongst many others. Anyway, each image for now contains only black pixels, so time to actually create these passes. That happens in the material. For each pass, I'm going to create an AOV output node and specify the correct name. Albedo, Roughness, and so on. All these passes, but the opacity are of type color, so I'm only interested in the color input pin, okay? For the opacity pass, I'm just interested in outputting a value of 1.0, that's it. So that's how I'm going to generate the PBR passes. See, if I do a render, I get to see the updated opacity. Alright, let's start with the roughness pass. First I'm going to create a UV map node. By the way, I found no better way to visualize what I'm working on but to use the materials emission pin. Let me know in the comments below if you can think of a better solution. Also, feel free to share if you have any tips to improve this overall workflow. I'm just sharing what I know, but Blender has not been my main priority for a long time now, and the software is progressing at a huge pace, so it's hard to keep track of all the new features and workflows. Anyway, using a separate XYZ node, I can isolate the horizontal gradient of that UV map. Let's subtract 0.5, get the absolute value, and multiply by 2 to create a bilinear gradient. I might even use a power operation to control the gradient's fall off. And use a 1- operation to invert it as well. Using a mix node, I'm going to set the base roughness to 0.8 and then say 0.25 around the edges. And I'm going to highlight the center line just a tiny bit, like so. Voila, that's my roughness map for that grass blade. Simple, but should provide a somewhat interesting specular behavior. I'm for now eyeballing things though. Values may need further tweaks once tested in engine with the proper lighting condition. For the specular map, I'm going to do the same thing, except that I'm going to flip gradients around and use quite low values overall. Again, that's just an example. That's assuming that's the artistic direction you're aiming for. And it's quite fun to try new things with grass shaders, try new looks and so on, especially for stylized rendering, of course. Anyway, regarding the albedo pass, well, I'm going to use similar tricks to generate color gradients. I'm also going to use the random value Blender generates per object to bring in some extra color variation per grass blade. There are plenty of shader tricks to think of here, but I'm keeping it simple. For the normal path, I can simply remap the world space normals to a 0 to 1 range and flip the white channel. For the random path, well, you guessed it, the object's random value will do just fine. And finally, the height path. That one is a little bit more involved. I'm going to create a cube. Display it as bounds, prevent it from being rendered, enter edit mode to offset vertices by 1 unit in Z. So select all, press G, Z and 1 on the numpad. Then I'm going to scale it down by 50% and apply the scale. Next, using a texture coordinator node, I can specify this cube to generate object coordinates, isolate the Z component to create a vertical gradient, and therefore generate a height map. Just have to scale the cube in Z and shift its Z position to create the desired range. Finally, for the transmission, I may simply use a top-down gradient derived from UVs as well. Voila, at that point I just have to do a render to save all PBR passes to disk. Rendering a single grass blade is quite dull though, so let's create a couple of grass clumps. I'll fast forward a bit here, because in the end it's just a matter of duplicating that one grass blade, entering edit mode, and use proportional editing to move vertices around and create interesting shapes and whatnot. You may fool around with modifiers as well, like bend, twist, and so on. The sky's the limit, let your creativity speak. So do that to create a couple of grass clumps variants, but be sure to leave enough room in between clumps. That's very important to prevent bleeding. More on that topic in a second. Anyway, that's pretty much it. I'm just going to update the height range and that's it. Press render and tada! Here comes a very annoying part, dilating textures. See this albedo texture? You might think it's good to go, right? Import it in UE, use its RGB components to drive a material's albedo and the alpha channel for the opacity mask. However, notice the black outlines that are creeping in the more distant I am to the mesh. If I get rid of the texture's alpha channel, I can see that albedo pixels were written where there was an alpha value, even the tiniest amount, hence the aliasing. It's a binary state, and that's totally expected. However, that albedo texture is scaled down by half, and then half more, and again to create what we call the Mip chain. That's to allow the rendering engine to sample very few pixels from that texture if the object is teeny tiny on the screen. It's an optimization trick, as well as a way to prevent aliasing, and it's great. The downside, however, is that a texture starts to turn into a blurry mess the further you go along the Mip chain. Therefore, pixels that are outside this opacity mask gradually participate more and more in the final color. In other words, the background color is bleeding in and you get black outlines. So to prevent this, textures have to be dilated. And there are many solutions to do this. Photoshop is of course a solution, but I'd rather suggest a free and open source alternative. You may for instance use GIMP and its value propagate filter. Set it to more opaque, click OK, and tap Ctrl F until the texture is entirely flooded. Then reapply the initial alpha channel and voila! Visually it's the same, but now background pixels are no longer black but contain colors. And that's one solution. You can also of course duplicate the layer, blur the underlying one, merge, rinse and repeat, and reapply the alpha channel. You can probably build a script in GIMP to do that for you. Image magic is probably a solution as well. There's probably a command line that exists to batch process a bunch of images all in one go. Now, dilating textures come with two important gotchas. One is file size. For instance, dilating a texture using a blur results in an image that is mostly comprised of smooth gradients, and it's the worst case scenario for most image compression algorithms. Large blocks of the same color would instead be ideal. Second gotcha, dilating a texture doesn't really solve the black outline problem. Well, I mean, it kinda solves it, but not in an ideal way, although it's usually good enough. You see, pixels from the background are going to bleed in no matter what, and so in the distance you'll get to see some of that background color creeping in. The thing is, most dilation algorithms work from the edges. Therefore, the dilated background color is going to be biased towards the edge color, if that makes sense. Something that may be very apparent if, let's say, for some artistic reasons, you have very bright edges, right? And actually, the same issue appears in other textures as well, and roughness and specular maps may quite often feature that kind of edge treatment, especially for grass, right? Thus, bright edges may result in a bright dilated background, which is going to bleed in with Mip maps. Again, it's not usually a big issue, but it's something to know. So dilating textures can be a pain in the butt. It's a process that comes with a few technical subtleties, and that, I believe, still for most artists, involves a lot of manual labor, meaning lots of clicking on buttons. So to solve the file compression, edge bias and time-consuming process issues, a new technique was presented at GDC 2019 called Mip Flooding. And someone was kind enough to release a Python script that implements it for free. Alright, so there are a couple of steps to make that Python script work in Blender, but hopefully nothing too problematic. First, I'm going to open this GitHub page. Link is in the video description below. I'm also going to give the author a shoutout. Thanks for the script. Now, if you're familiar with Git, you may get the files with a pull, but downloading the zip from the GitHub page also does the job. So I'm going to unzip it and voila. Next step is to create a Python script in Blender, like so, and use the code sample provided on the Git page. Now that Mip Flooding Python script uses the Python image library, aka PIL, or its fork Pillow. The thing is, Blender comes with its own version of Python, and it does not have that image library, so I need to install it for that specific Python version. A very annoying process to figure out when you don't know what you're doing, like me, but here's what worked for me. As usual, feel free to do things differently. I'm going to open a command prompt in Windows in administrator mode. Using the cd command, I'm going to navigate to where the Blender Python executable is installed. Using it, I'm then going to install pip. And finally, using pip, I'm going to install Pillow. And that should allow me to import PIL in Blender. Note, however, that PIL is not imported in that Python script. Well, I'm lying, it is. It's that Mip Flooding library that imports it, so it's definitely a requirement, okay? Therefore, the next step is to make that Mip Flooding library import work, because Python has no knowledge of it yet. So I'm going to copy the path where that library is located. Next, import sys, and make Python aware of that path. Voila, that should allow me to import this Mip Flooding library. Final step is to specify where my PBR passes are located on disk. Rename them so they contain the proper suffix. Tweak the script a little bit so that it processes all passes. And voila, run the script and images on disk should be flooded. You'll notice images are somewhat transparent still, but it's no biggie. The RGB channels are correctly flooded, so you can just get rid of that alpha channel or import images in UI without the alpha channel. Alright, I'm going to create a new scene. Shift A, Image, Mesh Plane, and open the opacity map. In the shading workspace, I'm going to use the color as alpha. Use the non-color color space, set the emission strength to 1, and set the render method to blended. Back in the modeling workspace, I'm going to change the viewport shading mode. Alt-A to deselect all, and I'm going to make sure I'm in vertex mode, so tap 1 on the keyboard to do that. And I'm going to right-click while holding Ctrl to create a vertex here. And keep doing that to detour that first group of grass blades. Now, there are a couple of things to think about here. Vertices must never be placed outside this canvas. It's very important for an upcoming step. I also want to leave some inner margin, just a bit. I want to leave some outer margin as well, like not to be too close to other groups, right? And of course, I'll want to think about the vertex count and how to use vertices to best minimize overdraw, meaning have the least amount of transparent pixels with the least amount of vertices. For instance, adding a vertex here would reduce overdraw by some amount. But is it worth it? Well, there's likely no right answer, up to you to decide. I'll also want to think about vertex animation, like how to place vertices so the card can be best deformed to apply good-looking wing animation and so on. Finally, I'll also want to think about how the card can be deformed and bent to create an interesting volume and silhouette and not just have a flat card. Don't worry too much about it at first though, this will come with experience. Anyway, I'm going to select these 4 vertices and tap the F key to create a quad and keep doing that until the whole card is surfaced. It's important at this point to make sure normals are facing the correct way though. So I'm going to activate the face orientation overlay, and if any geometry is shown in red, select it and flip the normals. Moving on, I'm going to add an edge loop here using Ctrl R. And with these 2 vertices selected, I'm going to press J to create an edge. And turns out I can place vertices like so to get rid of that unnecessary triangle. Cool. Oh, and actually I'm going to add a vertex here, add an edge with a JK, double tap G to slide that vertex along that edge to get rid of that triangle. That's going to allow me to extract a bit more volume from that card in the upcoming step. Anyway, that's LOD 0. I'm going to repeat the process for LOD 1 and 2, ideally reducing the vertex count by half each time. The last LOD should likely be just a single quad or even a single triangle when possible. Rinse and repeat for the other cards, and voila. I'm just going to make sure vertices all lay flat on that plane by scaling the object to 0 in Z. Next, I'm going to double check that no vertices lay outside the canvas, and it looks okay to me. Pressing 7 on the numpad to ensure I'm looking from above, I'm going to tap A to select everything, press U and select Project from View Bounds. And voila, UVs are done and cards are ready to go. Well, almost. I'm going to do one more step that is going to facilitate LOD's selection further down the road. So I'm going to say this material is LOD 0, duplicate it, name it LOD 1, and apply it to the LOD 1 cards. By the way, the L key is very useful to expand the selection to the whole mesh. Anyway, duplicate the material once more, name it LOD2 and apply it to the LOD2 cards. That way I can use the material selection feature to select LODs, and that will come handy in just a minute. Alright, we are almost done. I'm going to select this object and press Ctrl C to copy it. Create a new scene, and Ctrl V to paste it. I'm going to delete the canvas. Then I'm going to select this bit, press Ctrl L, and press P to separate the geometry. And rinse and repeat for the other cards. Next, in object mode, I'm going to recenter them and apply their location. In object mode still, I'm going to select all objects, press R, X and type 90 using the numpad and apply the rotation. Press Shift C to reset the cursor on the view. Select all objects, go to edit mode, tap 3 for the side view and select one of these vertices at the top. Next, I'm going to use the proportional editing once more with a sharp fall off to apply a reasonable amount of curvature. Same, looking from above, I'm going to bend the geometry just a little bit, like so. Finally, I'm going to isolate one of these objects and see how I can make these cards look a tiny bit more appealing. The goal is to try and make these cards have the maximum amount of pixel coverage when looked at from any angle. A flat card being the worst case scenario. Look at it from the side and it disappears, right? And so that's where being a bit smart with the way you create your cards is going to help. So yeah, it's all about using your best judgment and trying not to deviate too much from the higher LODs, because you likely have quite a bit of geometry to work with for the LOD 0, right? So you can likely create an interesting volume, sure. But keep in mind that this LOD 0 is going to quite abruptly transition to the LOD 1 at some point, and then LOD 2 and so on. So there's a balance to find, right? Tweak too much the LOD 0, and the LOD switch is potentially going to be quite noticeable in-game. On the other hand, it's a good idea to leverage the higher vertex count and add some extra oomph to that flat card, if that makes sense. Anyway, repeat the process for all cards, use Shade Smooth on all objects, rename them, and put them in a collection. The last step is to create the in-game grass assets. I'm going to create a linked duplicate of this collection. And I'm going to select all objects in that collection and press Alt-D 1 or 2 times to duplicate cards. Next, I'm going to use the randomized transform operator to spread these cards apart and then manually fine-tune the result. Here I'm just trying to ensure cards are somewhat evenly spaced out and that the asset has a decent silhouette and volume when looked at from any angle. And that looks good to me. I'm not being too serious about it, to be honest, it's an asset for a tutorial after all. Anyway, now is probably the time to bake pivots using my Data Baker add-on or your preferred method. And the reason I've kept LOD 0, 1 and 2 part of the same object is that I really like to bake a random value per card in UVs. It's extremely useful for lots of shader tricks, like say to offset the wind animation per card, or add a bit of tint variation to the albedo per card and so on. And the way my add-on works, well, this random value is generated and baked per object. So having separated LODs into different objects would have generated a different random value per LOD, and that'd be hugely problematic. Say I use that random value to offset the wind animation per card. Switching LODs in-game would result in a different offset and a sudden jump in the wind animation, right? So here I kept all LODs part of the same object to ensure they share the same random value, if that makes sense. But now that pivots and extra data are baked, and that all cards are merged into one single object, I can use the material selection feature to isolate each LOD. Then get rid of the LOD 1 and 2 materials, and export each to FBX. In UE, I'm then going to import the LOD 0, then the LOD 1, and LOD 2. I may then fine-tune the LOD's distances, but it's probably something to tweak once the grass asset is put in your quote-unquote game context, because in that preview window, well, it's hard to grasp the view distance. Anyway, I'm also going to add a material slot to say, hey, the LOD2 in the far distance is going to use a different grass shader, a much cheaper one. Before diving into that though, I want to mention a couple of things. One is texture packing. It's common practice to reduce memory usage, and I released on my Patreon a tool that lets you pack textures in engine. For instance, the height, roughness and specular maps could be packed into a single RGB texture. Same with the random and transmission maps or any other map really. Opacity is probably best kept as a separate image or packed into the Albedo's alpha channel for better compression, but you may disagree. There are no right or wrong ways to pack textures, it's up to you. Next topic, texture color space. I'll be brief here because this is a topic on its own. The gist of it is that ideally you should work in linear space, so sRGB should be disabled and your entire texturing workflow from start to finish should account for this color space. Next, texture settings. Not a lot to say here, grayscale textures should be set to grayscale, and packed textures to mask. Finally, texture usage. Most maps here should be quite straightforward, Albedo, Roughness, Specular and so on. You might however wonder what's the purpose of that random map. Well, this is usually great to add a bit of pixel depth offset and reduce that flat card look a little bit. Pixel depth offset comes at a cost though, and has issues with dynamic shadows, something to keep in mind. Same for the height map, it can be used to add some pixel depth offset, although, to be honest, it's probably not going to be that useful as is on grass cards. Height maps are mostly used for height blending two sets of textures, like with landscape layers, right? I just wanted to show you that it's possible to quite easily render a height map in Blender. Same is true for the transmission map. It could be used to drive the subsurface scattering amount or other things, but using a simple top-down gradient to do that is probably a bit naive and dull. But again, I just wanted to show you what's possible. Up to you to let your creativity speak, and up to you to output the gradients and color data from Blender that you need to build your own grass shader. Speaking of, here's a very simple grass shader example. This is quite a crude shader to be honest, and I'm just going to briefly go over it because building a grass shader is a topic on its own, and is out of the scope of this video. It's something I've covered in previous videos anyway. So here's the Albedo map, multiplied with colors based on a top-down projected noise texture, and the per instance and per card random values. Roughness and specular maps are lerped towards a constant value at a distance. There are tricks involving Mip maps to bake that behavior directly in the texture. Again, something I already covered in a previous video. Here's the opacity map with a shadow pass switch to dither it near the tips and fake light bleeding through the grass a little bit and casting a weaker shadow. Here's the normal map. Tangent space normals are used as world space normals, a huge hack, but whatever. Subsurface scattering. Some hacky wind animation using my spherical reprojection material function. And finally some pixel depth offset. At a distance that pixel depth offset is disabled, wind animation is turned off as well. Roughness and specular are both constants. Same for the normals, and voila. That's a decent looking grass asset. The real difficulty lies in building a large grass field that looks good under all lighting conditions, that feels natural, that obviously performs well, and that handles the far distance transition with the underlying landscape material well. A huge technical and artistic challenge. But baby steps, you know? Making a decent looking grass asset is a nice first step. You may practice by building extra variations, trying different looks and so on. Now obviously this entire workflow isn't tailored for nanite, because for now, I'm not gonna lie, I kinda hate what working with nanite means when it comes to foliage assets and vertex animation, so I'm sticking with the old ways for now. And yeah, I think that's it. That's my workflow for creating foliage assets in Blender. I'm sure there are steps that could be simplified and sped up, but it's all in all nothing too complex and I feel like I can get things done relatively quickly. That said, I'm hoping to drastically speed up the process with my upcoming add-on. It still needs a bit of work though, so stay tuned. Anyway, that concludes this 3-part series on realistic grass. Now this asset slightly leans towards stylized grass, but honestly there's pretty much no difference between creating realistic and stylized assets. The workflow is pretty much identical, it's all about artistic direction and how much time you spend on adding details and so on. You could for instance sculpt these high poly assets, rely on more intricate texturing techniques to generate the PBR passes and so on, but yeah, creating highly realistic assets should be no different than creating stylized assets. That's it for today's video. I hope you liked it. Files are available as a tier 1 reward on my Patreon. You can also find a ton of great educational UE projects, demos and assets, so feel free to take a look at it. Any support is much appreciated. Speaking of, thanks to all of you for sticking around, and thanks for your incredible support. You are the best. Alright, I'll see you in the next video. In the meantime, take care of yourself, enjoy your summer break if you have one. Bye bye!